test methods and standards for solar home system kits. The session today is a joint session that involves the Lighting Global program and the Global Off-Grid Lighting Association. And in just a moment, we'll introduce our speakers and we'll get started. Thanks again to everyone for joining. We realize that setting up one of these webinars spans a lot of different time zones, and so we appreciate everyone who got up very early or is staying up late to attend the session. So as I said, my name is Arnie Jacobson, and I'll be one of the presenters today. And I'll now pass it over to my two co-presenters to introduce themselves.
I'm Meg Harper. I've been a member of the Lighting Global Quality Assurance team for about 4 years now, and will be helping present the webinar today.
Hi, my name's John Keane. I'm here on behalf of GOGLA, the Global Off-Grid Lighting Association. I joined GOGLA just in September, so prior to that I was the CEO of Sunny Money and head of programs at Solar Aid, so I know the industry well.
Thank you, Meg and John. And John, really good to be working jointly with you on this, and look forward to working closely together going forward. So the session for today will start off with just a bit of brief background about the Lighting Global Quality Assurance Program. We'll move through that fairly quickly because I think many of you are familiar with it, but in case there are some who are not, we'll go over that. And we'll then spend some time summarizing the changes that were proposed to the solar home system kit test methods, to the original framework, and there are also some associated changes that influence the pico-solar products. We'll then take a bit of time to describe the feedback that was received, and we'll provide a summary of some of the changes that were made once that feedback was considered. I'll talk about the timeline for those changes to take effect, and then we'll spend a bit of time talking through some key topics for future consideration that don't involve changes that will happen immediately, but are topics that we think require some additional consideration. We'll pause for questions at a few places during the session, and then we'll also have time at the end for questions and answers. And we request that you please enter your questions in the chat window when you have them. As a point of background, the Lighting Global Quality Assurance Program is a joint initiative of the IFC and the World Bank. It supports and is closely affiliated with both the Lighting Africa and the Lighting Asia programs and the associated country programs in a number of countries in Africa and Asia.
Hello.
In the context of that program, we run a testing and verification program for off-grid energy products. We started running that program back in 2009 with a focus on pico-solar products, or products with solar modules smaller than 10 watts. The quality assurance framework associated with the program was institutionalized through the International Electrotechnical Commission in the form of Technical Specification 62257-9-5 in 2013. Edition 2 was the 2013 version of that document, and we're now on edition 3. It was published just a few months back. And in 2015, we developed jointly with the Fraunhofer Institute for Solar Energy Systems a framework that included test methods and quality standards for plug-and-play solar home system kits and we've been using that since last year. And a lot of the focus of this session will be on the Solar Home System Kit framework. The program is very much a joint program that involves a lot of partnerships. I won't talk through all of those partnerships here, but I will say that very key partnerships include, of course, the Global Off-Grid Lighting Association, the International Electrotechnical Commission, Fraunhofer Institute for Solar Energy Systems, all of which have played key roles in engaging with quality assurance. And then our newest partner, CLASP, which will play a leading role in the quality assurance program into the future. And we're really happy to have them on board as a partner. We also, of course, have a network of test laboratories that we work very closely with, and the labs that we're currently working closely with are listed on this slide as well. In terms of the framework or the elements of the program, it includes test methods and standards. And the test methods and standards, as I mentioned, were originally set up for evaluating pico-solar products, and there we work closely with the IEC and also manage a quality standard. In a bit, we'll talk about ways that that program or that element of the program has been expanded in the context of solar home system kits. We use those test methods and standards in the context of a testing and verification program where products are determined through lab testing to whether or not they meet the quality standards. Both the original qualification testing under the QTM or quality test method framework and any renewal tests that are conducted are carried out at labs that have ISO 17025 accreditation. We also have a market surveillance or market check testing effort that involves testing in products that are pulled from the field to make sure that those products continue to meet the quality standards once they're being delivered to markets. Products that meet the standards get a spec sheet and a verification letter, which are posted to the Lighting Global website. And there are also some additional mechanisms that are used to communicate quality to the market, for example, through consumer awareness campaigns that are associated with particular country programs. And as a program, we also engage quite closely with stakeholders, and there everything from engagement with the industry through GOGLA and also through individual interactions with companies. We engage with development agencies and other organizations that are involved in the sector, and also spend a lot of time engaging with governments, especially in cases where governments have indicated that they plan to adopt quality standards. And there we focus on working to help those governments adopt standards that are harmonized with the existing standards. The Lighting Global framework now includes both pico-solar products and solar home systems. With regard to pico-solar products, we spent a bit of time talking about those already, and that testing activity has been going on since 2009. At this point, more than 200 products have been submitted for testing through the framework, and well over 100 have met the standards. Currently, those that are listed on the website, a number somewhere in the 80s, so maybe 80 to 85 products currently meet the standards among the pico-solar products. In terms of solar home system kits, here the framework is focused on plug-and-play kits, and of course with larger modules. Until recently, or until we're discussing this now, the focus has been on solar home system kits with solar modules ranging between about 10 watts and 100 watts. But as we'll discuss a bit later, we are the plan is to increase the maximum size of that, and that will be one of the key things that we'll talk about. The test methods are currently in the form of a document that's called the Lighting Global Solar Home System Test Methods. And Lighting Global also has a quality standard for solar home system kits. Neither of these documents has yet been submitted to or adopted by the IEC, although there is a plan to submit the test methods to IEC. And to date, we've tested 11 products, and there are a few more that are under test, and 8 have met the standards. This screen shows the solar home system kit products that are currently listed on the Lighting Global website and that meet the Lighting Global standards, and we look forward to being able to list additional products in the near future. In terms of the timeline for the development of the solar home system kit framework, we began developing the quality standards and test methods beginning in 2014. That work was carried out as a joint initiative between the Lighting Global Quality Assurance team, the existing team, and the Fraunhofer Institute for Solar Energy Systems. We developed that framework using existing IEC standards and the pico-solar test methods as a starting point, and we drew from existing materials wherever it was possible to do that, and having incorporated stakeholder feedback along the way, and have also piloted the test methods and tested products, and then used that experience from the testing as well as the stakeholder input to update and revise the test methods where that was needed. In terms of testing services, they're currently available at 3 labs, one in China, which is SMQ, one in the United States, which is the Schatz Energy Research Center, and one in Germany, which is the Fraunhofer Institute for Solar Energy Systems. Lighting Global, Lighting Africa, and Lighting Asia are all offering support for quality verified solar home system kits in many of the same ways that they offer support for pico-solar products. Our plan is to include the test methods for solar home system kits in an updated version of the same document that includes the pico-solar test methods, and to create a single unified framework for products that goes up to 350 watts. And we anticipate that document would be published in 2017, probably in the latter half of 2017, given the timing for the review process within the IEC. And so we'd like to pause now just briefly to see if there are any questions that have come up to date, and if there are, we're happy to answer them, and if not, we can move on to subsequent topics.
We just received one question. It says, it seems you split items in 2 categories, SHS and appliances, and provide different tests or warranty for these 2. What is the situation if the appliance integrates itself in a SHS, an all-in-one system?
So we do, the testing that we do focuses on either Pico solar products or solar home system kits. But if solar home system kits are sold in a way that includes appliances with them, we do some high-level evaluation of those included appliances, mainly to ensure that we've captured how those appliances influence the overall performance of the solar home system kit, and also to make sure that the appliances meet basic durability and safety standards. However, in cases where those appliances have already met existing IEC standards associated with those types of appliances for safety and durability, then we accept those test certificates and don't do additional testing on the appliances, except the testing that's required to understand how they influence the system as a whole.
And we had another question. He says, the opposite question, what challenges do you foresee in moving away from the plug-and-play limitation?
So it is important to note that we have focused on plug-and-play kits rather than component-based systems, and we certainly could imagine broadening coverage in the future, although we don't have a current plan to do that, to cover component-based systems. But there are a number of challenges associated with doing that in the context of this sort of framework. And I think one of the main ones being that it's hard to represent system-level performance of systems, and to ensure that the end consumer will have a well-designed and well-functioning system by just looking at the components. You also have to consider the design of the system and issues associated with installation of the system. And a plug-and-play format simplifies some of those issues by the way that all of the components are considered together.
And we have another question from Joseph. He says, since IEC TS 62257-9-5 is a published standard, can testing be undertaken at any test lab that offers this testing to this standard? What is the difference in testing at a Lighting Global approved lab and any other?
So certainly the test methods can be used by any laboratory or any company. In terms of the test reports that the Lighting Global program will accept, we will accept test reports from labs that are ISO 17025 accredited with these particular test methods within their scope, and that have engaged with our program and have a cooperation agreement in place with our program. And we do that to make sure that there's a transparent process for sharing results between the lab and the program, and in order to make sure that the labs are following a consistent set of guidelines. With that said, we are ready to work with any lab that has that proper accreditation and is willing to engage with us.
And that's all the questions we have right now. Are you ready to move on?
Yeah, so let's proceed, and if you have additional questions, we'll pick them up at the next available opportunity. And so we'll spend just a couple of minutes talking about the test methods and standards as they relate to both Pico solar products and solar home system products. And so for Pico solar products, those products must be tested to the most recent edition of IEC TS 62257-9-5 and by a lab that is, as I mentioned, ISO 17025 accredited with those methods within their scope. And for QTM testing, which is the quality test method testing, which is the primary test that's required to determine if a product meets the standards, we use a sample size of 6 for each of the tests, and we collect those samples through random warehouse sampling, typically from a stock of typically 500 units or more, which represents about 3.5% of the warehouse stock if they have exactly 500 units. Those of you who are interested to obtain the copies of the test methods, they can be purchased through the IEC web store. And for many organizations, there is a discount that's in place which reduces the cost to well under $100 US for purchasing that document. For the solar home system kit testing, the tests are carried out according to the latest edition of the Lighting Global Solar Home System test methods, and in this case it would be through a lab that is approved by the Lighting Global program to conduct those tests. The sample size for those tests is a sample size of 4 in terms of the solar home system kits, and we sample from a warehouse stock of at least 200 units in those cases. The reason for the smaller sample size and the smaller warehouse sampling requirement for solar home system kits is not because of any statistical reason, but because we recognize that the cost to companies associated with providing a large number of samples is higher when it comes to the solar home system kits. And so as a practical matter, we felt it was necessary to reduce the sample size and the stock requirements in relationship to that. Those who are interested in getting a copy of the test methods can simply request them from us, and we will provide a copy in PDF format. And then in terms of the standards, we have 2 separate standards, one that focuses on pico solar products and one that focuses on solar home system kits. And both of those documents are available through the Lighting Global website as downloadable files. And the web address for that is located in the lower left-hand side of the screen. So the tests for pico solar products that are included in the current set of test methods cover a variety of topics. Some are component level tests and some are system level tests, and there are also a set of durability oriented tests. I won't walk through them one by one, but these are tests that have maybe shifted slightly over time, but have essentially been the same framework that we've used since starting the program back in 2009. Now that we've added solar home system kit tests, I think it's useful to briefly note that there are some differences between the test for solar home system kits and the pico solar products, and that mainly has to do with differences between those systems and the processes for evaluating them. Again, I won't walk through each one of these one by one, but I will note a few key differences. One is that for solar home system kits, we've added an evaluation of the ports that are used, and that includes both ports for or both tests for evaluating the power capabilities of the ports and the efficiencies, and to ensure that proper circuit protection is included. Another area, scrolling down a few where I think there are some important differences, has to do with how we evaluate the daily level of energy service that's provided by these systems. With pico solar products, we have focused on the daily runtime of the lights. And in a solar home system kit, because it's powering a larger variety of appliances, we focused on a metric that is related to the amount of energy that's delivered on a daily basis rather than just lighting. And so that's required some differences in how the testing is carried out. And there are also some additional differences associated with things like evaluation and requirements for warranties, for user manuals and packaging, etc. And we would encourage people to both download the standards to evaluate that, and we'll also make these slides available after the talk. So again, we can stop briefly here and leave time for questions in case any have come in.
And we already have one question. Someone noticed that in the picture we showed that the pico wattage range is less than or equal to 10 to 15 watts peak. And they said, is this correct? I thought it was less than or equal to 10 watts peak.
And there, our focus historically has been primarily on products that are less than 10 watts peak. However, some governments have adopted frameworks that were largely harmonized with the Lighting Global test methods and standards, but used a 15 watt upper limit. And so in order to accommodate that and to allow companies with products in that 10 to 15 watt range to be able to move through the process and have products that met standards in those countries, we have allowed products up to 15 watts to be tested using those methods. And so there is a bit of overlap there between the solar home system methods and the pico solar methods, or there has been over the last few years. And so we leave it up to companies to decide within that range which approach they would like to take.
And that's the answer to the follow-up question of where do 12 watt peak products go, pico or SHS. And right now we are allowing companies to choose which method they would like to be tested under if they're in that 10 to 15 watt range. And part of the purpose of this recent stakeholder feedback was to determine what that threshold should be and set it so that it is less confusing going forward. And that's our plan. The next question is, can we consider to reduce the sample size for pico stock, 500 pieces, especially for some pico SHS, which are less than 10 watts, since it's hard to get a big stock during the early production stage?
I think that's something that we would be willing to discuss. I think our primary concern has been making sure that the samples that are used for testing are representative of production as a whole, so that the products that are being evaluated are neither cherry-picked or somehow misrepresent the full stock. And so we're willing to discuss, and have always been willing to discuss, approaches that would ensure that the golden sample issue was not there, but and provides the rigor that's needed while still making the approach practical for companies. And several companies have indicated that the sample size of 500 is a barrier in some cases, and we feel that's an area that merits further discussion, and would posit that having a discussion in the context of engagement through GOGLA could be a good platform for having that discussion.
We have another question. What is your policy going to be for testing SHS that include a mains inverter, especially as regarding safety?
To date, we have not. Our focus is on plug-and-play kits that are DC only, and so at this point we don't accept products that include an inverter or mains level voltage. That is something that we could consider and would be willing to discuss in the future, but we would have concerns about some of the safety aspects that would need to be addressed in that context.
Okay, one last question, two last questions for now. How do small entities avail themselves of the discounted IEC standard from the IEC web store? And this is, there's a link on the website, and I can send it out through when I send the materials with this presentation later today, where you can sign up to see if you are see if the discount is applicable to your organization, and then you should receive a discount code and that you'll be able to use at the IEC web store. And if you have any trouble with that process, you can let us know, and we'll try to troubleshoot for you. And then Paul Wade asked, have any unanticipated teething problems been encountered in expanding the QA scope to include solar home system kits?
I would say sure, yes. I don't know if they're unexpected, but whenever you're rolling out a new test method or moving into a new area, there are challenges that come up. I would say that one of the main issues is that there's a huge amount of innovation that's going on in the sector, and products, even fairly small products, have become increasingly complex, and that can make it challenging to have a set of test methods that covers all of the different issues that might come up in the context of products that come through. And so I think historically we've tried to be as flexible as we can in terms of finding practical solutions when products are designed in a way that wasn't originally anticipated by the methods themselves. And I think in most cases we're able to successfully do that, but I think those sorts of issues are always coming up, and I think always will in the context of this sort of work.
Okay, we have two more questions, and then I think we should return to the webinar. What is our position on a pico-type product that runs a small fan off a panel during the day without batteries?
I don't think that it's necessary to have a battery in order to necessarily be evaluated through our framework. And so I think in that sort of case, if a company is interested in submitting that sort of product, they should contact us, and we're happy to talk through the issues, and if necessary, develop a custom test plan to be able to evaluate that sort of product. We haven't had something quite like that that's been submitted before, but I don't see why we wouldn't be able to accommodate and evaluate such a product.
And then coming back to safety, even low voltage kits can present an energy safety issue. How is that addressed?
And so in terms of an energy safety issue, I think my interpretation of that is the question that relates to either arcing or short circuits that are associated with the battery. We do have overcurrent protection requirements in place that are intended to address that, and we also have we also evaluate the circuit to make sure that it's protected from reverse polarity and short circuiting and other sorts of things. And then in terms of arcing, the size limits and voltage limits associated with the products are set at a level that is intended to minimize any danger associated with arcing when plug-and-play connectors are disconnected.
And how is photobiological safety and flicker addressed to prevent damage of eyesight?
We don't have specific requirements associated with photobiological safety, although we have spent a fair amount of time thinking about this topic and have published some eco-design notes in relationship to this topic. And one of the people on this on the webinar is one of our experts in that area, Kevin Gauna of the Lighting Global Quality Assurance team. And we'd be happy to put you in touch with him if there are follow-up questions in relationship to that topic.
Okay, I think we should move on.
So moving forward, the methods in the pico-solar test methods are originally designed for fairly simple lighting products with at most one port for mobile charging. And so although we've adapted them in a number of ways to address more complex products, the level of complexity is now quite high, even for products that are sort of in the 5 to 10 watt range. We see a number of products with multiple appliances, some of which have their own separate batteries within them, etc. And that range of complexity is one of the key challenges associated with evaluating the quality of these products with a single set of test methods. And so in that context, some of the things that have been developed, some of the test methods that have been developed for solar home system kits, in reality should also apply in the context of pico-solar products that are designed essentially as very small solar home system kits, or essentially as multi-appliance, multi-light type systems. And so going forward, the proposal is to extend or adapt some of the tests that are associated with basically to extend some of the test methods that were developed for solar home system kits to pico-solar products that have some of those characteristics. And so things like the ports test and the way that energy service or daily energy service is evaluated, instead of using some of the existing methods that were originally designed for pico-solar products that were single light and perhaps with only one port, for those multi-appliance, multi-light products, we would use the corresponding solar home system kit tests. And so this slide shows which areas the new test would apply in the context of the more complex pico-solar products, and where they would not apply. And again, I don't want to walk through them one by one. I do think that it's important to note that in many cases, applying these new tests replaces existing tests. And so in terms of overall cost of testing for many products, the difference will, we think, not be significant. For products that are very complex, though, the cost of testing goes up regardless of which version of the test methods that are used. And so we do think that the cost of testing, manufacturers who have fairly complex products that include a number of different included appliances are likely to see testing costs that are higher than the average testing cost for basic pico-solar products. So just walking through the stakeholder process as we've gone through it. So we received and incorporated feedback on an early draft of the solar home system kit test methods and standards a little over a year ago in September of 2015. We requested additional feedback on a proposal to integrate the solar home system kit test methods into the IEC 62257-9-5 document in June of this year, June of 2016. And we compiled comments and provided responses in a stakeholder feedback document that we released recently. And that document is available through the Lighting Global website. We plan to incorporate a number of proposed changes. The changes to the solar home system kit test methods will be made in the existing Lighting Global Quality Assurance Protocol, or the test methods for solar home system kits, and then also will be submitted for inclusion in the IEC document. The changes that end up influencing the Pico solar product testing won't go into effect until the next edition of the IEC document is published, which is sometime in the second half, likely sometime in the second half of 2017. So I guess, again, to summarize, the changes that relate to solar home system kits will go into effect very soon, essentially immediately, but changes that we're discussing now that would affect Pico solar products wouldn't go into effect until the fourth edition of the IEC document is published. We, of course, plan to continue to engage with stakeholders regarding any changes to the QA framework, and updates are published on our website on the stakeholder engagement page. And of course, we'll continue to engage through the Quality Assurance Working Group of the Global Off-Grid Lighting Association, and working quite closely with John and colleagues at GOGLA. So we want to thank everyone for the feedback that they have provided, and that feedback has spanned a number of different contexts and stakeholders, so we really do appreciate that. In terms of this particular feedback process, we received responses from 12 different organizations, and they spanned a variety of different types of organizations, and inspired more than 30 distinct changes to the QA framework and the proposed plan for solar home system kits. In addition to these 12, we also had detailed discussions within the IEC working group that is associated with managing the 62257-9-5 document, and so feedback from those conversations was also included in this context, and in addition had some conversations in the context of the most recent GOGLA annual general meeting that influenced the process and thinking as well. When we receive comments, just to quickly go over that process, we of course read and summarize those comments, and sometimes we'll follow up with clarifying questions to individual commenters where that's needed. We then discuss those comments within the Lighting Global Quality Assurance team and with key collaborators, in this case the Fraunhofer Institute for Solar Energy Systems, and then also discuss key issues with the Lighting Global, Lighting Africa, and Lighting Asia program managers from IFC and World Bank. We'll typically conduct research on topics where that's needed in order to make sure that we're drawing where needed from existing documents and standards, and that where needed we're looking into all of the technical nuances of a particular situation. In this case, we've had follow-up conversations with individual stakeholders, with GOGLA and with the IEC Technical Committee. We'll then present the responses in a feedback document. We'll present and discuss key issues in the context of forums like this webinar, and then as the next step after this webinar, we'll incorporate decisions into the quality standards and the test methods.
And we have recently released, as Arnie mentioned, a stakeholder document that summarizes all of the comments that were submitted during this most recent round of stakeholder feedback, as well as presenting the changes that we've recently made based on a prior round of stakeholder feedback. That document is available on the Lighting Global website, and I encourage you to read through it. There's a summary at the beginning and then detailed information throughout. And thank you again for all of your input. It's very useful to making our program better. And right now I want to run through some of the major changes that we've implemented based on our proposal and the stakeholder feedback we received. The first, as Arnie mentioned earlier, is we've increased the peak power limit from 100 watts to 350 watts. And this was largely a change based on stakeholder feedback that there were a number of companies that wanted to include larger systems in our program. And we had a long discussion with members of the IEC and other technical members to ensure that we felt that our methods could adequately address these larger systems and that they would not cause safety hazards. And that's how we settled on 350 watts, and the maximum nominal voltage for these systems would be 24 volts. Another major change, as Arnie mentioned earlier, is we're going to begin to require the assessment of DC ports, the energy service calculations, and related tests for all products with ports, so that the energy service calculations can be used in place of conducting multiple solar runtime tests and full battery runtime tests. And this will allow us to evaluate multiple settings and multiple combinations of lights and appliances, and we believe these will be more appropriate for these types of products that we've discussed. We are currently doing some validation testing to ensure that these methods will be appropriate for smaller products, and we plan to, once we finish with that testing and make any small adaptations to the methods based on that testing, we plan to submit the revised test methods to the IEC. We would also plan to require the miswiring test, the PV overvoltage, and the output overload test for all products with ports, regardless of size. And we would also, for any appliances, we would require the voltage range compatibility test. These tests we consider the protection tests, and we think that it's appropriate for all products with ports to undergo these tests. They're just basic safety and protection tests for both the user and the system. And then the other big change that we mentioned earlier is that we plan to set the dividing line between product classes at 10 watts based on the PV panel rating. Right now, as we discussed earlier, the dividing line is a blurred 10 to 15 watts, and we've had discussions with some of the country governments that had set that higher 15-watt rating, and they said once we are covering larger systems, they would be comfortable with a 10-watt division between product classes, and we felt that that was a more appropriate dividing line. The dividing line is largely meant to separate products that would need to submit a sample size of 6 from products that would need to submit a sample size of 4. And we believe that the sample size of 6 is more appropriate and will provide better results, but we don't think that with the higher cost of products and the larger size, we don't think it's appropriate for us to require that large of a sample size for larger products. And this 10-watt dividing line would also apply to a few other standards for solar home system kits, such as the need to submit a wire and cable sizing declaration, the need to have a statement on their packaging regarding battery replacement, some user manual guidelines, and some increased warranty terms, which we'll discuss in a moment. There are some other key changes. One was to increase the lumen maintenance threshold for all products from 85% to 90%. At this moment, solar home system kits are required to maintain 90% of their light output after 2,000 hours, and based on data that we've received or that we've gathered over the past few years on pico-products, we believe that nearly all pico-products can meet this same threshold, and we think it is appropriate at this time to increase that threshold and have one more metric that is the same throughout all products. We've also, because we are increasing the testing burden for some products, we're always looking for ways to minimize the time and cost of testing. And one way we've identified is to stop measuring the usable surface area with illumination greater than 50 lux. This is a metric that we found useful in the early days of the program, but since that time we've rarely seen products that advertise this, and it is a fairly confusing metric for most people to communicate and fully understand. And so we've decided we will still measure the light distribution to categorize whether the product has a narrow, wide, or omnidirectional light distribution, but we will not take the time to measure the illumination on a plane. Another change is we've decided to decrease the warranty requirement for solar home system kits to 2 years for the system and the battery and 1 year for all appliances. Previously it was 3 years for the system, 2 years for the battery, and 1 year for all appliances. The main reason we've decided to make this change is based on a number of people pointing out that having the separate 3-year and 2-year requirement could lead to confusion and possible conflicts in cases where if a charge controller failed in the 3rd year and damaged the battery, it would be unclear whether the battery should be covered or not, and similar cases. And so we've decided on a 2-year warranty for the system and battery, but as we are simultaneously extending from 100-watt kits up to 350-watt kits, we're realizing that a 2-year warranty may not be appropriate for a much larger system. And so we're interested in talking through what an appropriate warranty period might be for larger systems, and what the dividing line should be for those. And a final key change that we made is, and this is a change that will go into effect immediately, is we are amending the passing thresholds for the switch, gooseneck, connector, moving parts, and strain relief durability tests to no longer allow any failures. For pico-products, we used to allow 1 product to fail these tests. So if you're testing 6 products, 1 of them could have a failed switch, and we realized that one of the main aspects that our tests are not completely catching in the field are issues with switches and connectors. And we feel that tightening our thresholds is one very simple step we can make, and then we'll discuss a little bit later, we're interested in designing some more tests to better evaluate switches and connectors so that we can make sure that we prevent failures in the field. I wanted to talk through the implementation timeline for these changes. As Arnie mentioned earlier, most changes will take effect after the revision of IEC 62257-9-5 is published, and that will likely be in the second half of next year. But the following changes will take effect immediately. These are changes that are being made to the solar home system kits. And so we don't need to wait for the IEC document to be published. And one change is to increase the size limit. The change in the warranty requirement will take effect immediately, and then that change to the durability thresholds, or the thresholds for the durability test, will also take effect immediately. And at this point, I want to pause for questions. Feel free to enter any questions you have in the chat window. And it looks like we have a number that has accumulated here, and some answers as well. Let's see.
I think the most recent one that came in was is with respect to solar home system kits with lithium batteries. Are there any additional or special requirements, such as for a BMS, which I think means a battery management system in this context? And the answer is that there are charge control requirements for all products, and those charge control requirements are tailored to the particular battery type. So there are requirements associated with lithium iron phosphate batteries as well as others.
And we're also, for lithium batteries, this has been a standard for solar home system kits, and we plan to extend it to pico-products as well, but lithium batteries must carry a UN 38.3 certification, and that is a basic certification that nearly any lithium battery will have to be able to be shipped around the world. So it may require a little bit extra paperwork, but any decent quality battery should have that. And there's also a requirement if you have a lithium battery that has multiple cells. There are some overcharge protection requirements for individual cells or sets of parallel cells. The next question is a pico product whose panel and batteries can be scaled such that the device can also fall into the SHS domain. How would we proceed with testing? That's a good question.
So I think there we have a family of products policy that allows us to develop a custom test plan when evaluating products that have a similar set of common components, or which are scaled in the way that's described in this question. And we have evaluated and developed custom test plans for product lines that span from Pico solar products up into solar home systems. And so the way that we do that is through our family of products policy. And so we would encourage people to look at that policy, which is available on the website, or to follow up with us if you have questions or would like to discuss that policy.
And then it looks like Kevin, a member of our quality assurance team, provided some feedback on the photobiological safety issue and wanted to let people know that we do have 2 eco-design notes, issue 2 and issue 4, that are available on our website that cover photobiological safety of LED lights, and also that cover some of the testing that we've done, and provide recommendations to manufacturers on assessing their products for photobiological safety. So please look into those, and I hope that helps address that earlier question. Chris Moeller says he noted in the response to stakeholder feedback an understandable concern to avoid being prescriptive about particular solutions, but can you say if you choose to use XXX in your product, then we will test for the following issue?
I guess it probably would make sense to follow up and discuss that question, because it seems like it's a general hypothetical that is a little bit hard to answer in the abstract. I think in terms of how we approach testing, we focus on really a couple of things. One is truth in advertising and making sure that products perform as advertised, and then the other is for a limited key set of metrics, evaluating the durability of products and making sure that they meet both durability and safety requirements. So we'd have to look at the specifics of what you're asking to be able to say whether or not the test methods would be able to cover that particular thing.
Understood. Thank you.
And David asked, why is 15 watts a more reasonable dividing line than 10 watts?
And I guess we're not arguing that 15 watts is a more reasonable dividing line. We have proposed 10 watts as a dividing line in this case. So it is the question saying that 15 watts would be preferable, or that 10 watts would be preferable. To date, we focused on 10 watts and have made a provision for companies historically to test products up to 15 watts as pico-products, but mainly just to accommodate the fact that some governments had set their thresholds at that level.
And how did you come to the 350 watt peak limit?
And so the 350 watt peak limit, I think, is the result of several things. One is that there were a few companies that were quite interested in moving above the 100 watt threshold. In fact, we're interested in move well above it if possible. And so there was some stakeholder interest from the manufacturing side around increasing the limit. We then sat down within the IEC in Technical Committee 82 in order to discuss some of the safety issues and thresholds associated with plug-and-play kits. And what we determined by considering a couple things was that there was a need both to have a voltage threshold, a maximum operating voltage threshold, which is 35 volts, and that is related to safety issues associated with products that might be used in damp locations, and we would consider a solar module as always going to be in a damp location at some point, because there'll be rainy days. And then the 350 watts, that limit was set based on concerns about the potential for arcing when plug-and-play connectors were disconnected once you got above a certain set of voltage and current thresholds. But the determination was that at 350 watts and below, it should be relatively safe, and the level of arcing shouldn't pose a particular hazard. There was some interest on some companies to go even above 350 watt level, and at this point we're not in a position to do that based on the feedback from the IEC Technical Committee, but we certainly are open to discussing that in the future, or to explore ways that some of the safety issues could be addressed in particular circumstances.
Another question we had is, if the PV module with cable is 10 watts and the power of the PV module without the cable is 9 watts, does it belong to SHS or PICO? I think at this point we are going with the rated PV power, so it would depend on what the rating of that module is. And I would have to say that cable is amazing to create an additional watt. But it would, if it is rated, if it's a PV module that's rated as a 10-watt module, then we would treat it as a solar home. Or
actually, 10 watts.
10 watts would be.
10 watts would be pico. Would be above 10 watts, where it would not be.
But if your question was 11 and 10 watts, then the 11-watt rated module would be a solar home system kit. And does the warranty requirement mean anything more than checking what the manufacturer says? Obviously, I'm concerned that warranties may be very difficult to take advantage of in the field, but this seems way outside product testing.
That's true. I think as a program, we have focused on having a requirement that there be a consumer-facing warranty, and we evaluate the product advertising to make sure that there is a consumer-facing warranty, and there are some specifics associated with what we look for there. We also, from time to time, will do field checks where we'll make sure that warranties are being presented to end consumers appropriately in a market setting as well. But as a program to date, we have not been in a position to evaluate how warranties are serviced and to enforce that dimension of warranties. We agree that doing so would greatly strengthen the effectiveness of warranties, but there are major challenges associated with doing that in practice. And so to date, that's been outside of the scope of what we've been able to do.
And Ashwin asks, could you mention a little more about the key changes around energy service calculations and power delivery calculations? Is the simulation method accessible to the manufacturers?
So the test methods are available on request, and so certainly the test methods are available to manufacturers. And if there was a manufacturer that was interested in conducting those sorts of tests in-house in order to evaluate their own products, we certainly would be willing to talk with them and to, once they've read through the test methods, and to provide advice about how they might implement that. We always encourage manufacturers to try and do that testing in-house ahead of time so that they're confident with what they're doing before submitting the products.
And I think we can move on. So the next few slides, we have about 20 minutes left, and I wanted to run through a few items we're still considering for the future and some technical questions that we would love to get some feedback on. And we'll run through about 5 of these and then be open for questions and comments after that.
And also wanted to leave just a little time at the end as well for John Keene of Gogla to make to say a few words as well. So we want to make sure that we don't eat up all of the time.
And so the first issue is we have an outdoor cable policy that requires cables to be rated or tested for water and UV resistance for solar home system kits. This policy is something we've been developing in consultation with several manufacturers, and we plan to begin enforcing in the end of February 2017. And there have been a number of stakeholders that have suggested that we should extend this policy to pico-products, to products less than 10 watts as well. We're interested in getting feedback from stakeholders on whether this is a significant issue for these smaller products that do tend to have shorter lifespans, and whether manufacturers of these smaller products believe that they would be able to meet this requirement. The policy that currently applies to solar home system kits is available on our website. If you do look at it, it currently has a date of implementation as December 2016. We are extending that as we do a little bit more validation testing on that. The next issue we're interested in is determining appropriate warranty periods for larger solar home system kits. As we discussed, we have reduced the warranty period for solar home system kits to 2 years for the system and battery, and included light points, and 1 year for all appliances. In our stakeholder feedback, we realized that this warranty period seems appropriate for the low end of solar home system kits, but may not be providing enough protection for larger products. And so we're interested in getting feedback on whether we feel this is an appropriate warranty for a 350 watt product, and if we don't, what the warranty period should be and where the dividing line should be. Another issue we're interested in is determining appropriate performance reporting requirements for solar home system kits. Currently, solar home system kits must report the PV power on their packaging, and that's in contrast to pico-products right now must report the light output and solar runtime on the highest setting. Stakeholders emphasize the importance of providing consumer information to manage user expectations of solar home system kits, and we're wondering if there are additional metrics that should be consistently reported across all solar home system kits. The obvious choice we've thought of is watt hours per day, but we feel that that is a little bit esoteric and difficult for to explain the meaning of. And so we're interested in ideas of if there are other metrics that would make sense to report across all require all solar home system kits to report, and how it would be best to implement performance reporting requirements and communicate the performance of these kits. Another question we had is more of a technical question. Right now, for USB ports, our policy is that they must provide between 4.5 and 5.5 volts at all battery voltages. These limits exceed the recommendations of the USB battery charging specification, which has slightly tighter voltage restrictions of 4.75 to 5.25 volts. The reason we extended our voltage limits is largely to accommodate Nokia phones and some popular smartphones that do charge at 5.3 or 5.4 volts. And we've also allowed the voltage to be pulled down below that 4.75 limit because it allows the charging efficiency to be improved in the case of linear charging. But there have been some concerns that by going outside of the USB battery charging specification limits, we may be setting ourselves up to
there may be some products that could be damaged by those higher voltages.
Yeah, and so we're wondering if anyone has feedback on whether the extended voltage limits that we've proposed are acceptable as safety requirements, or if you have any additional information on this topic. And one last topic for consideration is that we are interested in improving our durability tests for switches and connectors. We've had reports from the field that there are a number of quality verified products that do still have failures due to switches or connectors and we want to be able to better catch these issues during the initial testing. And so we plan to develop methods, and we're interested in any feedback or recommendations from your own internal testing or from methods that you know of for assessing switches, the durability of switches and connectors. And we're also interested to know if there are any other key failures that you're seeing in the field that we should be considering in our testing. So those are some of the key topics we're very interested in still receiving additional feedback on, and I'm sure there may be others as well. So right now we'll be open for questions for another few minutes, and then we want to leave some time for John Keane to speak at the end. And it looks like we've gotten one additional question from Newt, and you should have a look into the new draft of IEC 62368 for the USB issue. Excellent.
Yeah, thank you for that, and we'll pursue that.
And we have, if the PV cables are made of rubber, maybe the UV test is not needed. For the connectors only used during installation, it should be conducted 100 cycles, not 1,000, which that is one change that we have made for all products to the upcoming methods, is that if there's a switch that is only used generally once when you first turn the product on or first set the product up, that only is required to go through a 100 cycles test. And Lua also suggests IEC 60598. Are there any other comments or questions at this point? Okay, we'll move on and be open for comments again at the end. So just to reiterate, our immediate next steps are we're going to make updates to the quality standards for solar home system kits and pico-products. The main changes will be that 350 watt limit, 2-year warranty for solar home system kits, and increasing the durability passing thresholds for the durability test. We're also working to finalize the validation testing of the energy service calculations, and once we have done that, we plan to submit the revised test methods with the proposed changes to the IEC. We expect the revised version to be published in the second half of 2017. And then, as always, we plan to continue researching and collecting feedback on select topics, some of the ones that we mentioned and as well as others. And at this point, I'd welcome John Keane from GOGLA to speak for a moment. We are at Lighting Global, we are always interested in your feedback, and GOGLA has a strong interest as well to ensure that your feedback is being heard and communicated.
Thanks, Meg, and thanks to Arnie as well. Obviously a huge amount of work you guys and your team have put into the ongoing development of these methods and standards. So, you know, for anyone who isn't aware, GOGLA is the industry association. We have 80 members, and a key part of my work is to ensure that I think the views and issues and concerns and needs of the industry are heard and discussed and fully represented. So I think my end goal will really be to engage with our members in the coming weeks and months to help ensure that there's more stakeholder participation and feedback to contribute to this process going forward. So I think my email's there at the end, jkeen@gogler.org. So if anyone on this call is interested in discussing how Gogler can get involved and how you can get involved through Gogler through feedback to this process, do get in touch. Any Gogler members on this call, we do have a working group, a technology working group. It meets every 6 to 8 weeks, and it specifically discusses quality assurance issues. So the next one is scheduled for mid-December. So again, get in touch with me. I'll be keen to talk to you. All right, thanks.
Great, thank you, John.
Yep.
And at this point, we are open for questions for another few minutes, if anyone has any, but that's the end of what we had to share with you.
Yep. So thanks, everyone, and we'll just stay on the line in case any additional questions come through.
We just got a question that says, I assume the slides will be shared, and yes, they will. I will send those a link to the slides out following the webinar, along with a recording of the webinar. We have not been taking notes on the answers. I can provide a list of the questions, and there will be a recording of the webinar that you can listen again. We see had a comment that said, great job, but it's going to get harder and harder as solar home systems get more and more versatile. We fully agree. So thank you all. I think we're going to turn the webinar off now. Have a great rest of your day.
Thank you.
Thanks, everyone.
Thanks.